tied to a tree on a frictionless, snow-covered hill. If the sled weighs 77 newtons, find the magnitude of the force exerted by the rope on the sled and the normal force exerted by the hill on the sled. So, ang hinahanap natin dito is the normal force and the force tension, yung ina-exert ng rope dito sa sled. Let's draw the forces acting on the sled. First, we have the weight, and then the normal force, which is perpendicular to the surface. And then we have the force tension. Yan, force tension. If we turn it into a free body diagram, magiging normal force over normal force, and then not this. This is the weight, and then we have the force tension. Yan, weight. Yan. Ayan. Meron daw ditong angle of 30 degrees. So, right here, we have an angle of 30 degrees. But, ayan, since, imagine this is a triangle, 30 degrees, and then this is 90 degrees, we can also assume that this is 30 degrees. Teka, I'll just redraw the diagram. Yan. There. We have 30 degrees here. And we can get the components. Yan. First, we can look for the force tension. So, the force tension is on our horizontal axis. To get the force tension at X, tatandaan natin yung force, which is mass times acceleration. There's no motion in the sled, so acceleration is 0. Therefore, force is 0. And let's write the forces acting on the sled. 0 is equal to force tension minus the weight of the sled. And pwede nating i-move dito. And force tension is equal to the weight of the sled. And to get the weight of the sled, yan, force tension, we have 77, but kailangan natin malaman yung weight of the sled at x-axis, and naka-incline siya. So, we're going to use the components. We're going to use 77 Newton sine theta, or sine 30 degrees. 30 degrees. Now, you may be asking, why sine when horizontal yung ating sinusolve? It is because yung angle natin, it is positioned right here. Kapag ni-rotate natin yan, vertical siya sa angle na to. So, sine 30. And we will get the force tension of 38.5 Newton. That's the force tension. Now, susunod natin nga hanapin is the normal force, which is placed on the y-axis. So, at y, again, summation of forces is equal to mass times acceleration. And since wala namang movement yung sled up and down, there is 0 acceleration, therefore 0 yung force. And let's write the forces acting. Yan, 0 is equal to positive normal forces minus the weight at y. Minus the weight at y. Move natin dito, and we will get the normal force is equal to the weight of the sled. We're going to solve it. Weight, kailangan natin yung vertical component niya, which is weight times cosine theta, and that is 77 cosine 30. Again, y cosine, kung vertical ang pinag-uusapan, it's because nandito naka-place yung angle. Ayan, and then when you solve, we get the value of 66.7 Newton, and that is the normal force exerted on the sled.